Okay, this is section 15.6, radical equations and problem solving. Okay, so our first application problem here is using something called the Pythagorean theorem. And in the Pythagorean theorem, it says if A and B are lengths of the legs of a right triangle, and so here is leg A and here is leg B, and it doesn't matter which one is A and which one's B. And C is the length of the hypotenuse. Then the formula A squared plus B squared equals C squared means that if you take the square of leg A's measure and add it to the square of leg B's measure, you will have the measure of the hypotenuse squared. And we can make use of that to solve a lot of very realistic, useful problems. So first, we'll solve one that's just simply a geometry problem. Find the length of the hypotenuse of a right triangle when the length of the two legs are 2 and 7 inches. Okay, now, just because I call it a right triangle doesn't mean that the triangle has to have the angle in a certain place. This is the right angle. It just simply means that angle is 90 degrees. And my hypotenuse is going to be C, and that's what I want to find. And I can arbitrarily decide which is A and B, but one of my sides is going to be 2, and the other one is going to be 7. And so in order to determine what C is, what I will do is I will take 7 squared plus 2 squared equals C squared. And 7 squared is 49. And 2 squared is 4. And 49 plus 4 is 53. And 53 equals C squared. And so that gives us, if we take the square root of both sides, and take advantage of the fact that the square root of C squared is equal to C, then we know that C is equal to the square root of 53. And that is what's referred to as an exact answer. And we keep that 53 under the square root. Now, realistically, if we were doing something in real life where we actually wanted to measure that, then we would take the square root of 53 using a calculator. Then the calculator will tell us that C is going to be approximately, and let me do a little better job of that. C is going to be approximately, which is what little wavy equal signs tell you, 7.28. And this indicates that this is an approximation. And you'll have to watch carefully to see which way your answer is supposed to be entered. So this one says find the length of the leg of a right triangle and give the exact length and a 2 decimal place approximation. And it says that one of the legs is 2 meters, and the other piece of information we have is that the hypotenuse is 9 meters. And so the first thing we would do is we would usually draw a sketch, because it kind of helps us with these kinds of problems. And so this is going to be 2 meters, and this is going to be 9 meters, and this is going to be the other leg, which I'm just arbitrarily going to call it B. And so C squared, which is 9 squared, is equal to A squared, which would be 2 squared, plus the other leg, which is B squared. And so 9 squared is 81, and 2 squared is 4, plus B squared. And we need to subtract 4 from both sides. And 81 minus 4 is 77 equals B squared. And so B equals the square root of 77. And that's your exact answer. And the square root of 77, again, using a calculator, is 8.77. And that's your approximate answer. And so we'll keep moving to our next example. And this one is a somewhat more realistic example, because this is a surveying problem. It says the surveyor must determine the distance across a lake at points P and Q shown in the figure. And to do this, she finds a third point R that is perpendicular to the line PQ. And so this is the line that she apparently knows the distance of. And she also knows that this is a perpendicular line, which is what makes that a right triangle. And so she wants to find the hypotenuse of this right triangle. And basically what we're doing then is we're using A is 240. So we're going to refer to this as side A. And she happens to know that the distance across the lake here, which is a long distance, is 320. And so what we're trying to find in this case is the other leg, which we'll call B. And so we'll use the Pythagorean theorem to figure this out. So we have 320 squared is equal to 240 squared plus what she's trying to find squared, which is B. And we definitely will want to use a calculator for this one. So 320 squared is 102,400 and 240 squared is 57,600. And that's going to be, whoops, not equal, plus B squared. And so that tells us that b squared is going to be the 102,400 minus 57,600. And that is 44,800. And so we will take the square root of that. And even though that's approximately 211.66, and we need to make that to the nearest whole foot, then we're going to say it's about the distance is about 212 meters. Because remember, this is a word problem, and so we always want to actually answer the question that's in the word problem. There are also some other formulas that contain radicals. Some applications involve formulas like the Pythagorean theorem is well known, but some others, such as the velocity formula, are not quite as well known, but they are equally useful, especially to people in law enforcement and physics and all kinds of scientists. The formula used to determine the velocity, v in feet per second, of an object after it has fallen a certain height is v is equal to the square root of 2gh, where g is acceleration due to gravity, and h is the height that the object has fallen. And gravity is approximately 32 feet per second. So we want to find the velocity of a person falling 5 feet. And we're going to round our answer to the nearest tenth. And so their velocity is going to be equal to the square root of 2 times 32 feet per second. And their height is 5 feet. And so then v is going to be equal to 2 times 32 is 64, and 64 times 5 is 320. And feet times feet is feet squared per second. And so then their velocity is going to be the square root of 320. Which is 17.88. Which we're going to round to 1/10, and that's going to be 17.9. So the velocity is approximately 17.9 feet per second. And that is how you work that problem. And those are the only two problems that we have as applications for the lesson on 15.6. But if you run into problems on your homework for 15.6 and you need help, just let me know, and we will work through whatever that problem is.